Okay, this is 8.3 homework help. The first problem gives us two vectors, 2, 5, and 5, -1. And it gives us this expression right here, which says some number times vector A plus some number t times vector B equals this. So I'm going to plug in the vectors that they gave me. So I'm going to have some number times vector A, which is 2, 5, plus some number t times vector B, which is 5, -1, equals 14, -19. Now from there, you can distribute, because one of the properties we learned about in the notes of vectors is that when you take a scalar, which is a number, times a vector, you just multiply it through. So what you're going to have is 2s, and I'm going to also group the x's together. So I'm going to do the same thing here. I'm going to multiply the t together, so I get 5t, and I'm going to set that equal to the x coordinate of this vector, which is 14, because the x coordinates have to add to be the x coordinate of the vector on the right. I'm going to do the same thing with the y's, so I'm going to distribute the s and get 5s, distribute the t and get -1t, and that's going to equal the y value of this vector, -19. So from there, I get a system of two equations with two variables, and you can solve this system by any method you choose. I'm going to multiply through the bottom one by 5, and I'm going to replace that then with 25s minus 5t equal, all right, -95. So I'm going to cross this one out now, just so I can add these first and last ones together here. And that gives me 27s equals -81. Divide both sides by 27, and I get s equals -3. And then I can plug -3 back into this equation up here, in which case I get -6 plus 5t equals 14. Add 6 to both sides, you get 5t equals 20. Divide both sides by 5, you get t equals 4. So I get -3 and 4 for mine. Okay, the next problem says a truck is traveling due north at 40 kilometers per hour. So we've got the truck heading north here, 40 kilometers per hour. And then on the perpendicular road, the police car is traveling west at 35. So we have 35 kilometers per hour. Both vehicles reach crossroad in exactly 1 hour. So if we multiply by 1 hour, then that would give us a distance, because distance equals rate times time. So they gave us a rate and a time, so we could find the distance here, which multiply by an hour, the hours cancel, and you just get 35 kilometers. So I'll just write 35 kilometers. Same thing here, you just get 40 kilometers. So that gives me distances now, because that's what it asks for. It asks for displacement. It says find the vector currently representing the displacement of the truck with respect to the police car. So basically, what that's kind of asking is if you place the axis here, like an x and y axis, or if this is your starting point, where is the truck in relation to the police car? Well, it's this way, which is back 35 down 40. So we'd say -35, -40, and use the vector brackets for that. There's your vector xy ordered pair. Okay, the next question says, give the velocity vector for the wind blowing at 5 kilometers per hour southwest. So let me just draw that here. That'd be 5 kilometers. I'll just leave it as 5 for now. Southwest means that we're at a 45-degree angle southwest. So here's south, here's west. So there's our vector. And we're going to give it in vector ordered pair notation, like we did the last problem. So we're going to break this up into x and y. So all we have to do is do cosine of 45 degrees equals, because this is 45 both here and here, equals adjacent over hypotenuse. So it would be x over 5. Multiply both sides by 5, and that gives you x. Do the same thing for y, and you'll do sine 45. These give you both x and y. Another thing you can do is use your special right triangle values, because special right triangle values, these are the same. It's isosceles right triangle. And this would be whatever the small leg is times the square root of 2. So this is like x square root of 2. This is like x as well, because they're the same. So, you'd set x square root of 2 equal to 5. Divide both sides, x equals 5 divided by the square root of 2. So basically it's -5 divided by the square root of 2, comma, -5 divided by the square root of 2, because we're going back that amount and down that amount. That's the exact same thing you'll get if you do this. You'll get a decimal approximation if you do this, but that's okay. This should work. Okay, the next problem is a tough one. It says that a large ship is being towed by two tugs. The larger tug exerts a force which is 30% greater than the smaller tug. So I drew this picture here. I drew this at 25 degrees south of east, like it said. I labeled this 1.3 F because whatever force the smaller tug's pulling with, this has to be 30% greater, which is 1.3. You know, the original amount was 1 plus 0.3 is the 30%. Now the question asks, which direction must the smaller tug pull to ensure that the ship travels due east? So the resultant of these two vectors when they're added together is going to have to be this vector here that goes along the x-axis right here. So what that means is that when I add these vectors together, the y components have to cancel, because you can break these vectors down into two components, x and y, and you can break this one down into two components, x and y as well. And this y has to be equal to this y. And the reason why is because if those y's cancel when you add them together, then what you're going to have is just to add addition of the x's, which will cause the boat to move in that direction. So that means that this right here, I'm going to label y, and I'm going to label this the same variable because those are equal. And I'm going to set up two equations. The first one is the sine of theta equals opposite over hypotenuse from the first triangle. The second one would be the sine of 25 equals opposite over 1.3f. Multiply both sides by 1.3f, and the 1.3f cancels. And multiply both sides of this equation by f, and then substitute, and you get f sine of theta equals 1.3f sine of 25. You're solving for this angle theta because that's what the problem asked for. So the f's cancel, divide both sides by f, and you get sine of theta equals 1.3 sine of 25. Take the inverse sine of both sides, and you get what you're looking for theta, which in this case is, it's 33.3 degrees right there. And that angle is up from east, so we would say north of east. Okay, this next problem I drew a picture of for you here. You got a 5 kilogram mass that's hanging, and we're looking for the tension, which I'll call F sub t right here, which is the force that's acting on both these clotheslines to keep this thing in equilibrium. If you draw, in physics we draw a free body diagram, so we draw the force down, which is the weight, which is mg, mass times gravity, and we've got these other two forces here, which we called F sub t, that are tension. Now, you can break these into their components, so this isn't probably a little bit more challenging than what I would ask you on a test. And this would be the y component, this would be the y component. They're equal because we have equal angles here. And this would be the x and this would be the x, and they're also equal and opposite, so they would cancel out. So, so what we can do is we know that both these y's, if you add them up, 2y has to equal mg, because these forces in the y direction here and here have to be all in equilibrium. So the 2 pulling up have to match the 1 pulling down, and so that's 2y equals, the mass is 5, gravity is 9.8, which I would give you on Earth in meters per second squared. Divide both sides by 2, and that gives you y is 24.5, and that's actually in newtons. So this is 24.5. Now the key is we need to find this angle. This angle is, if you look at this, this would be 5 and this would be 1 right here. So if you do inverse tangent of that, you can get this angle, which ends up being 11.3 degrees approximately. So you've got this triangle where this is 11.3 degrees, and now you can do inverse sine. So you can do sine of 11.3 equals opposite 24.5 over hypotenuse f sub t. Multiply both sides by f sub t and divide by sine of 11, and you get 24.5 divided by sine of 11.3. And that's the answer right there, which turns out to be about 124.9 if you don't round it all in the calculator. And so there's the tension right there. That's a tough problem and involves a lot of physics, so I probably wouldn't ask you one that hard on the test, but it's a good challenge problem. Okay, the next problem says a woman exerts a horizontal force of 5 pounds as she pushes the box up a ramp that's 4 feet long. So I drew a picture of this real quick. Now, I would tell you that work equals force times distance, so I'd give you that information if I asked you to do a problem like this, which I probably won't ask you to do when this is tough. But the other thing I'll tell you is that the force that you use has to be in the same direction as the distance traveled. So what that means is if we use a force of 5 pounds here, when you calculate work, the distance that you use has to be horizontal as well. So let's find this horizontal distance using this triangle right here. It's going to be, if I call this x, it would be cosine of 30 degrees equals adjacent over hypotenuse is 4. Multiply both sides by 4, and you get about 3.46. I'm not going to round that, but that's the distance I want to use right here, the horizontal distance. So if I multiply that by 5 in my calculator without rounding, I get about 17.3. And work is in this case foot-pounds, but they have the units there for us, so we're all set. Okay, the next question says find a vector A with goes from A to B here. So I'm going to graph both A and B. A is -1, 2, 3, 4, -4. And B is 2, 8. And we want a vector from A to B, so we want this vector here. So we want to go over 6, and we want to go up, and we're going to have to add the y values, but the so we want to go up 12. That's the vector we're looking for right there. You can draw this, and you want to find this x and y because that's what we're talking about here. Another thing you can do is head minus tail rule, so you could subtract these. So you do 2 minus -4, you get the x value, which gives you 6, and then you do 8 minus -4 to give you the y value, which gives you 12. So head minus tail rule says you take the head and you subtract the tail, and that'll give you the same thing. Problem 8 is another practice problem like problem 1. So reference problem number 1 if you get stuck on problem 8. Okay, the next problem gives us this vector 3i plus 5j. Now you might not be familiar with I and j, but I is the unit vector that goes over 1 up 0, and j is the unit vector that goes over 0 up 1. So to graph those, I is just this little vector here that goes over 1 unit, and j is just this little vector here that goes up 1. So you can rewrite things in terms of I and j. Let me show you how this works. So 3 times vector I is the vector 1, 0, plus 5 times vector j is the vector 0, 1. So if you distribute the 3, you get 3, 0, plus 0, 5. And if you add these together, you get the vector 3, 5. So it's actually really simple. This vector here just means you go over 3 to the right and up 5. So if we're going to graph that vector, which we should do now, we go over 1, 2, 3, up 1, 2, 3, 4, 5. So that vector goes over 3 and up 5. Alright, so now it wants us to check all these that apply. So the length of the vector is 34. That's not true. The Pythagorean theorem gives us the square root of 34 for the hypotenuse here if you do the x and y Pythagorean theorem for that. So square root of 34 is the length, not this one. So we're not going to cross that one, sorry. G is 1. Okay, so the next one, B, the vectors increase in length as you move away from the origin. That's not true. This vector, you can place it anywhere as long as you have the same square root of 34 as the magnitude and the same direction, so the same angle there, which gives you the same in x and y components, which is over 3 up 5. So you can place the vector anywhere as long as you go over 3 up 5. So that's not true. C, all vectors point away from the origin. Well, you can place this vector wherever you want. So it could go away from the origin, or you could place it down here. As long as you go over 3 up 5, it would point towards the origin. So that's not true. All vectors point in the same direction. That is true. The vectors decrease in length as you move away. Nope, they're all the same length. All vectors point toward the origin. That's not true either. You could have it point away like the one we first did there. So vectors, it doesn't matter where you place them, as long as you go over 3 up 5, you're describing this vector right here in the plane.